Everybody, and I guess it's just afternoon in Georgia. Welcome to the Clark Creek STEM Academy. You're looking at the International Space Station Flight Control Room. I'm Kyle Herring, Public Affairs Officer here in the room, and I'm joined by Pete Hasbrook. He is a Space Station Associate Program Scientist, so he's knowledgeable on the science activities that are ongoing. He's also been a long-time flight controller with NASA, so he knows all about what it's like to be a flight controller in the room. So we're really happy you guys are with us here in Mission Control Houston.
Thank you.
Good morning and good afternoon to you all. This is Pete.
Good morning, Mr. Hasbrook. Thank you. And may we present you with our first question?
Absolutely. We're going to do our best.
I'm as ready as I can be.
Hi, my name is Noah Bloomer. I would like to know, how is Curiosity doing?
How is Curiosity doing on Mars? Curiosity is doing very well, thank you. It's been doing very well going through its checkout. It's been going through its initial observations, and currently it's taken a long trek across the surface toward the center of the crater that we're going to observe.
Hi, my name is Oscar, and I wanted to know, how does a telescope work?
Kepler telescope. Work.
How does a Kepler telescope work?
The Kepler telescope, it looks like a pretty cool instrument. It's been in orbit for about 3 years, and it is looking for planets. The way it works is it stares at a certain part of the Milky Way, which is dense with stars, and it's looking for those stars to blink, basically. And if those stars blink, they can tell that a planet a planet may have crossed in front of that star and made it go just a little bit dimmer. It's got to be a very sensitive instrument. Think of, a light bulb way down at the end of the hallway and something like a piece of sand going across that light bulb, and you've got to be able to tell that the dimness of that light bulb changed.
Okay, go.
Hi, my name is Jacob, and I'd like to know, how far has NASA gone on building the Solar Cup from the National Geographic November 2012 magazine?
I have to say I don't know. I appreciate that you sent that question ahead of time. I tried to do some homework and I wasn't able to find the information on that one.
Wow. Okay.
So you stumped me.
Very good. Okay.
Didn't take long, did it?
Is NASA exploring what? Oh, yeah. Hi, my name is Brody, and I would like to know, is NASA exploring ways of living underwater?
Is NASA exploring living underwater? We have had several successful programs of crew members, station crew members especially, living underwater. They kind of practice living together as a team for a week or two at a time. They learn how to cooperate together, and they will go out and do what we call sort of a water walk instead of a spacewalk. They'll put on a suit, and they'll go out on the bottom of the ocean, and they'll simulate doing spacewalks and construction tasks and communication. So we have, I believe that we've finished that program. It was based off of the tip of Florida and the Keys. So it's been very beneficial to us. It helped our current crew members learn how to be team members on the ISS.
Go ahead, Graham.
Hi, my name is Graham. I would like to know, why did the shuttle program end?
The shuttle was very successful for us, and it did all of the work that we needed it to do. The shuttle was able to carry very large and heavy objects into orbit, and we used it to build the International Space Station, to launch and deliver many of the parts of the space station. And we knew that we had a plan for the whole space station, and when the space shuttle had delivered its last pieces of the station and its last cargo, it was time to finish it out. The space shuttle program, unfortunately, was a very expensive program to run, and we needed to use those funds for other things that NASA's doing, including the space station, including the Kepler telescope, and including other instruments.
Hi, my name is Nicholas. I would like to know, how is the Kepler spacecraft controlled?
How is it controlled? It's out in orbit around the sun. It's sort of near the Earth, but it's not in orbit around the Earth. So it points at a certain fixed place in the Milky Way, looking at stars. And if it were to drift, and the only reason it would drift is because of solar wind, it has little reaction wheels, or maybe big reaction wheels. But as those gyroscopes spin, you can push against them and sort of push the telescope back to where it's supposed to be looking.
Go ahead.
My name is Nathan. How likely is it that the planet of Earth can be hit by an asteroid?
Well, from what I know, it's fairly unlikely. We do the best that we can to track asteroids that are out there beyond the Earth's orbit. But if it were to happen, it would be very severe impact, obviously. So we do pay as much attention to it as we can. And NASA is looking in the future to figure out ways to what to do if we think something would intersect the Earth's orbit.
Hi, my name is Parker. I'd like to know, when your body is chemically and mechanically digesting food, why don't astronauts regurgitate their food due to the microgravity in the space station?
Great question.
That's a good question. I agree. If you think of your own body and you think of the pictures of your stomach and your intestines, if you look at those, they kind of go zigzag all over the place. So they don't always go down. Sometimes they go up, sometimes left and right. So our bodies have already developed the mechanism to move food through the intestines so that we can digest it. So really, once you get to space, it's not much different.
Okay, go ahead.
Hi, my name is Mac, and I would like to know which new planet shows the most promise to be inhabitable by humans.
I don't know a good example for you, but I know that Kepler, for instance, is finding what we believe are a lot of new planets around stars that are in our Milky Way galaxy. And some of those planets are at the right distance from their star, their sun, to be in what they call the habitable zone, where it's not too hot, it's not too cold, and there may be liquid water, and there may be conditions that would support life, at least as we know it.
Okay, go.
Hi, my name is Declan. I would like to know what a solar flare is.
A solar flare. On our sun, there are solar storms, and we also call them sunspots. And sometimes those spots have a big eruption, and they'll put out a very large plasma, I'll say, eruption that goes out into space. And generally, those aren't a problem for us unless the sun is turned so that that sunspot is facing the Earth. And then that very large amount of radiation that's put out could be a problem for us, and they call that a solar flare. Could be a problem for us because it sends radiation toward the Earth. You may see more auroras as that radiation is coming through our atmosphere. And it's also a concern to us because the astronauts who are in space are up above most of our atmosphere and most of the radiation protection that we have here on the ground.
Hi, my name is Hunter. I would like to know, how does the spacecraft differ from the rocket? How are they similar?
The spacecraft and the rocket. As you look at a rocket, it's very tall, and it takes a lot of propellant to get a spacecraft, whether it's got a crew in it or a satellite, to get that spacecraft up off the ground and into orbit around the Earth. So most of the rocket that you see is the bottom, probably 9/10 of that rocket, and it's full of propellant, and it's got some engines in it, and its whole job is to get that little spacecraft, little in comparison, up into orbit so that that spacecraft can do its mission.
Hi, my name is Joe, and I would like to know, is Curiosity controlled by Mission Control?
It is controlled by Mission Control, but the Curiosity Mission Control is not here in Houston. It's out in California, and it's at the Jet Propulsion Laboratory, I believe. And they are very experienced with controlling the rovers on Mars, and they have a little different way of operating because they can only see Mars at certain times of the day, whereas here in Houston we have continuous satellite coverage and the ISS is going over the Earth around us and in view continuously.
Yeah, so this room that you're looking at here, and maybe we can get a wide shot of it for you. You may have seen it at the beginning, but this is human space flight, and so we're watching over the International Space Station here, all of the flight controllers you see at each one of these consoles. And for curiosity, there's a mission control, obviously, like Pete said, that they oversee all the instruments on that rover as well. Great question.
Mr. Hasbrook and Mr. Herring, we are not able, our image from from Houston is just frozen. We're not seeing mission control. I didn't know if that was, but when you mention, when you look at mission control, we're not getting that view. It's just a frozen picture.
Oh, okay. Well, I guess you can see it behind me, but there's a bunch of consoles that flight controllers support.
No.
Look over all the systems.
We do not see anything mission control. It's been the same picture since we've been giving you our questions.
Okay.
Oh, there you are. Yay. Now we see you.
We're back.
Excellent.
I think we had a little technical glitch there, but
thank you. Great. Thank you.
I'm Pete over here.
Hi. Pete. All right.
Hi, my name is Amelia. I would like to know, how possible might it be for cosmonauts to land on an asteroid?
We think it is very possible. An asteroid is relatively small, so it's not going to have much gravity. So really, instead of landing on it, we're going to fly up next to it and figure out a way to anchor ourselves, or at least keep the spacecraft near that asteroid. And then the crew, if they're going to explore it, will have to put on spacesuits and go out and airlock and again somehow maneuver along that asteroid. But the gravity is not going to really easily keep the crew or the spacecraft next to it. It's a good challenge.
Hi, my name is Samira. I would like to know, how does space travel positively affect the human body? How does it negatively affect the human body?
That's a good question. As far as positively affect it, other than being weightless and being able to maneuver very easily, I have a hard time thinking of how it's positively affected. There are a lot of risks that we have to keep track of. It's easy to lose your muscle tone if you're not pushing off of things or walking to keep your muscles in shape. We know that the crew members' bodies, their bones, lose bone mass, which is significant, especially if you compare it to osteoporosis, which older people have here, where their bones get weaker. Another thing that happens in space is with no gravity, the fluid that normally is pushed down into our legs can shift up into the crew member's chest, and their face starts to look puffy, and that's something that they get over. It just looks a little funny their first couple of days in space.
Hi, my name is Lauren, and I would like to know, what types of weather do cosmonauts experience in outer space?
What types of weather? Really, the crew members inside the ISS have an environment just like you and I have here. It's what we call a shirt sleeve environment. You don't need a coat. It's nice and warm and comfortable. The humidity is just like you and I experience. When they go outside the space station, though, even though it's a vacuum, we do have to worry about probably two things at least. One is the sun. In the sun, things can get very hot. When you're not in the sun, like on the dark side of the Earth, things can get very cold. The other type of space weather, and that's what we call it, is space weather, is the radiation environment. So if the crew members were outside on a spacewalk and there was a solar flare that was directed toward the Earth, then we would be concerned about the radiation. And if it was severe, we would bring them back inside as soon as we could.
So, with respect to your answer with the last question about positive effects on the human body, there's really no positive effects on the human body with space travel?
Well, you get taller.
That's true. You and I, as we stand on Earth, are affected by gravity, and our spines are always compressed. That's why you might have heard in the morning when you get up after you've been lying horizontal all day, your spine has relaxed a little bit and you're a little taller in the morning, perhaps, than you are at the end of the day. Whereas in space, you don't have gravity always pulling you down, so crew members get an inch or two taller.
Yeah.
Hi, my name is Genesis. Now I would like to know, do the astronauts have computers on board the space station? If so, are they Mac or Microsoft?
They have a lot of computers on board. Most of them are laptop computers, and there are a couple of different kinds of software. The space station software, I think, is Linux-based. It's a very technical language. The laptops that the crew uses for their timelines and their procedures and for their email, I believe those are Windows-based. And then we do have a couple of new tablet computers on board, and I'm not sure of the operating system for those.
Yeah, not either.
Go ahead.
Hi, my name is Georgia, and I would like to know, how does the high iron content of Mars's soil affect the idea of visiting the planet?
How does the high iron content? I'm not really sure. I do know that we're able to land Mars rovers and other landers on Mars, so the iron doesn't affect it in that way. They may be able to use that iron for some kind of a benefit in construction if we were going to use Martian soil. But beyond that, I probably am not qualified to guess anymore.
Hi, my name is Leslie, and I would like to know what new planets are being discovered by Kepler.
Well, that's a good question. Kepler, as it's been staring at the sky for 3 years, they have identified something over 400, I think, possible planets. And they, as they say, have confirmed, I think, over 100 that they are pretty sure are planets. And that may be just by Kepler. It may be using Space Telescope, the Hubble, or another one to look at the planet, the star, after they found what they think is a planet. The types of planets that we can see they're either very close to that star, or maybe in the habitable zone that I talked about, or maybe farther out. So they may be very close and very hot, heated up by that star, maybe in the zone where there's mostly gas and water, or let's say methane liquid, or they could be farther out and totally frozen, kind of like Pluto and Neptune are.
Hi, my name is Melanie, and I'd like to know, are there experiments using recyclable materials on the ISS?
Is that recyclable materials? Is that what you said?
Yes.
Okay.
Yes.
Most of what we recycle would be the atmosphere of the station and the water that's in the station. The crew, as they urinate, we are able to recycle that into pure water and take the anything contaminating out of it. As the atmosphere becomes humid, we need to take the humidity out, and we're able to, as we say, reclaim the water out of the atmosphere. We also are able to take the carbon dioxide and regenerate that and either it's a chemical reaction that will regain some of the oxygen out of it. As far as recyclable hard materials on board, I can't think of very many on the ISS. I do know that we're working on a program for future exploration to be able to take the trash, whether it's food containers or bottles or duct tape, and turn it into little tiles that might be used for radiation protection. Something that the crew can take their trash and make it something useful, maybe put it around the inside of their spacecraft or their sleep station to protect themselves.
Go ahead. Just read your question.
How do solar flares or solar storms affect the space station?
That's a good question.
How do solar flares affect the space station? When a solar flare heads toward the Earth, all that energy and all that radiation can tend to heat up the Earth's atmosphere, and so it expands a little bit. And even though it's mostly a vacuum around the ISS, there is just a very, very thin bit of atmosphere. And the space station is dragged a little bit by that atmosphere. So if we have a solar flare and the atmosphere expands, we get a little bit more drag on the space station, and it tends to lower our orbit. So it may mean that we need to do a reboost earlier to stay in orbit.
What would happen if your spacesuit or EMU became infected with fungi?
I think it would be unpleasant. You could be, it depends on what the fungi is, whether you're reacting to it. You could be itchy. We do take very high precautions to make sure our spacesuits are clean after each use. The crew wipes them out with a fungistat cloth and lets them dry and make sure that nothing's able to grow in there.
What will happen to the Kepler spacecraft after its mission is completed?
After it's completed, it will pretty much just stay in the orbit it's in right now. It is in a sun orbit, so it's like the Earth. It's going around the sun. It's, I don't know how many 100,000 miles behind the Earth in that orbit, but there's really no danger to the Earth to leave it out there. And once it's finished, we'll just leave it there and move on to the next thing.
Go.
How is the moon different from a planet?
How is the moon different from a planet? That's a good question. I had to look up the definition. And a planet has to satisfy three things. It has to orbit a star, in our case the sun. It has to be generally round, so have been there long enough to have its gravity make it into a sphere. And then thirdly, it has to have really cleared its orbit around the sun or around the star. And so the Earth has done all those things, and really that last item is what got Pluto in trouble. It hasn't been there long enough to have cleared all the other asteroids and junk out from its orbit. Now the moon is orbiting the Earth, it's round, and it's really cleared our area, but since it's not going around the sun, you can't call it a planet.
Go.
How is nanotechnology being used in space?
That's a tough question, and I don't know if I know enough. I do know of one experiment where we're using nanoparticles. It's called In Space, and it's what they call a colloid, which is suspending very tiny particles in a liquid. And so in this case, those would be nanoparticles. And then when you apply a magnetic field around that liquid, it changes its properties. And in this case, it can become more dense. So that's an area of research that might help us in the future in shock absorbers, making them lighter. Earthquake dampers is a good example.
Are there any NASA underwater research centers like NASA's Aquarius? If so, where are they located and what is being studied?
NASA Aquarium? Is that what the question was?
Aquarius.
It was Aquarius.
Any more?
Oh, Nemo or
Why don't you go ahead, Kyle? Talk about Nemo.
Pete already referenced the underwater, the Nemo, where crew members in the same kind of environment could learn how to live together in space for long periods of time. The only underwater facility that we have near here is where the astronauts train for spacewalks, because it's they can simulate the environment of what it's like outside the space station. In fact, we have astronauts out at the swimming pool. We call it the Neutral Buoyancy Laboratory right now, training for their mission to the International Space Station. You probably can see that, and so it simulates what it's like outside the space station. So that's the closest thing we have near here to an Aquarius, I guess.
All right, and we're coming up on a minute left. If we'd like to go ahead and say our goodbyes now, I'd really appreciate that. We had some awesome questions today. So Clark Creek STEM Academy, would you like to say thank you and any final words?
I don't know if they can still hear us, Michael, but we've had a great time, and those were some really great thought-out questions, tough questions. So we really appreciate y'all coming and joining us here in Mission Control and letting us come and join you there in Georgia. You guys have a great day.
Great question,
Thank you
Joel.
so much. We love NASA. Thank you. Awesome.
Y'all take care. Bye-bye.